Hello navigators. In today's lecture, we'll talk about a method in which you can apply a one-dimensional physics into your simulation. For example, you have a wall which does nothing but conducts the atmospheric heat to the system, or it takes heat away from your system and gives it to the surrounding. For that, your wall thickness is so small compared to the entire domain that if you mesh that particular wall, then it will take a lot of mesh elements, and that will make your simulation very heavy. In those cases, you may want to look for a method in which you can describe your boundary as a shell element, and you solve your physics in two-dimensional domain, and then after solving it, whatever flux or heat or energy you get from the surrounding or from the system, and you want to give it back to the other side, so that you can easily do using that kind of a system. You can also use this particular method to solve something like a lubrication problem or friction problem, in which you are just concerned about what is happening between the contact between two surfaces and how the friction or the lubrication is working. For that, you can use the method in which you can describe the surfaces using finite area. You remember that you cannot use finite area alone. You need a finite volume mesh to use finite area method in OpenFOAM. Let's get started.
Thanks for watching, and if you like the content of our channel, then please like, comment, share and subscribe.